Salutations, mini mathematicians. Thanks so much for joining me. This is part 1, the 1.3b lesson, and we'll finish the rest of it on Wednesday. So taking a look, 1.3b, here is your notebook purpose, transition to numerical expressions. Our purpose is using number sentences, find a markup, a percent increase, or mark down, percent decrease or discount. Be aware of the questions asking for a final price or just the amount that we're increasing or decreasing by. So starting with this table, we're going to be looking at 2 word problems and how those numbers correspond to it. So we had Pedro had $600 in his savings account, and then 5 years later he has $800. So here our GCF, a number that goes into both of these, the biggest number that goes in both of them is 200. So I'm going to look at the first model of $600, and that's going to be 3 sections of 200. But if I was going to model $800 using 200, notice that is going to be 4 sections of 200. So our fraction change, what is the change from 600 to 800? Well, this is the amount of change right here. So this is 800 is 1/3 more than the original. If I wanted to look at the fraction of the original, so if I look at 600, 600 is 4/3. Sorry, fraction of the original. This is 4/3 of the original. If we look at this as 3/3, and so this is 4/3 of the original. So our percent change is our fraction change. These are going to be the same, but it's just as a percent. So 1/3 is 0.3 repeating, which we can say is 33.3 repeating percent, or 33 1/3%. So we know that this is a 33 1/3% increase. And then the percent of the original, well, if you want to look at the percent of the original, this is 133 1/3% of the original, because this is 4/3. Percent of the original is related to the fraction of the original, which we know is 1 1/3, which we know is 133 1/3%. So we know that this is 133 1/3% of the original. And that's going to be important when we look at our number sentences. Because if we write the fraction change expression and percent change expression and simplify, if we have 1/3 more than the original, we're starting with 600 and we're increasing it by 1/3 of 600. Or we can think about this, or this would be 600 plus 200, which gets you 800. Or you can be thinking about it as 4/3 of 600, which also gets you 800. If we looked at this as the percent change, we can look at this as 100% of 600 plus, we need to have this percent as a decimal, which we might want to use it as a fraction, but okay, I guess we'll have to use it as a decimal because they want us to use decimal. 600 times 0.3 repeating, which we know this is 600 plus 200, which gets us 800. Or we can think about this as this is 100% and this is the 0.3 or 33 1/3 repeating percent. So we can think about this as 100 and 33 1/3% times 600, which is also going to get you 800. So let's look at something without a repeating decimal. I think it might make a little more sense. So let's look at Naya. She used to take 10 minutes to walk to school, and now it takes her 8 minutes. This is going to be a decrease. This is going to be a decrease. So if we look at this, originally it took her 10 minutes. The greatest common factor with 10 and 8 is 4. So how many boxes of 2 do I need to make 10? That's right, it's 5. Let's make each section 2. And now it's only going to take her 8 minutes. So now I only need 4 boxes. So if you want to look at a fraction change, it's 1/5 less than the original. And if you look at the fraction of the original, this is 4/5 of the original. If we look at a percent change, 1/5 less than the original is a 20% decrease. And a percent of the original, 4/5 of the original, is an 80% of the original. Notice with a percent decrease, these two numbers are adding to make 100%. Because if we're not taking 20%, we are taking 80% of the original. So looking at this with numbers, if we had 1/5 less than the original, we can think about this as 10 minus 1/5 of 10, which is 10 minus 2, which gets you 8. If we look at 4/5 of the original, so if you're not taking 1/5, you are taking 4/5, because you can think about this as 1 minus 1/5 times 10, which would get you 4/5 times 10, which also gets you 8. If we wanted to look at the percent, we can think about this as 10 minus 20% of 10, which will get you 10 minus 2, which gets you 8. Or we could also think about this as 100% minus the 20% of 10, which is just the 80% of 10, which gets you 8. So something I do want you to write down is another equation is that its percent of change is final minus initial all over initial. This is going to be an important formula for this lesson and the rest of this module. So sometimes when we're looking for the percent of change, it's final minus initial all over initial. Thinking about we're relating it back to what we had, that's why our denominator is our initial or our original whole. Perfect. Let's turn the page. I'm going to do number 2 with you and 4, and then you're going to do the other problems on your own. Okay, so the directions say write a number sentence and solve the following problems. You may also use a model if helpful. State your answer in a complete sentence. So, Lee planted a 12-foot tall tree in her yard. 10 years later, it is 18 feet tall. What is the tree's percent of growth? So we're going from 12 feet to 18 feet. Our tree is growing, which is great. So it is a percent increase, which is nice to think about. So what we can do is we can find the percent of change. So remind ourselves the percent change is equal to final minus initial all over initial. So in this case, our final height was 18, our initial was 12, all over 12. 18 take away 12 gets you 6. 6 over 12 is 1/2. 1/2 we know is a decimal of 0.5, as a percent is 50%. So we can say that the tree's percent of growth is a 50% increase, or 150% of the original. Number 3, we're going to skip that for now. You're going to go back and do that. We're going to look at number 4. So number 4 says, last year Mrs. Howdy's class increased from 20 to 25 students. If her class size increases by the same percent this year, how many students can she expect to have in her class next year? So this is a two-part problem. The first part is step 1. We need to find the percent increase. And then step 2 is we are going to find the expected number. So percent increase, again, remember that is final minus initial all over initial. So her final number of students is 25 minus her initial, which is 20, all over her initial, which is 20. 25 take away 20 is 5. Over 20 reduces to 1/4. So this is a 25% increase. So what are we doing? We are taking 25, which is her new number, and increasing it by 25%. So we want 25 increased by 25%. So there's two ways we can do that. We can take 25 and we can add 25% of 25. Too many 25s. Never. Which is 25 plus 6.25, which gets you 31.25. Interesting answer. We'll talk about that in a second. Or we can think about this as 100% plus 25% of 25, which gets you 1.25 times 25, which is also 31.25. However, can you have a quarter of a student? No, you cannot. You cannot have a quarter of a student. So how many students would she expect? She can expect around or about or approximately 31 students next year. I am rounding to the nearest student. Awesome. Go ahead, pause the video here. You're going to finish. You're going to do 3, 5, and 6. 3, 5, and 6, and we're going to go over it as soon as you're ready. Let's see how you did. Number 3, if you got that the new price is $74.75. Great job. One way you can think about this is, since it's an increase of 15%, 65, your original whole, plus 15% of 65 gets you that new price. Or this is 100% of 65 and another 15% of 65, so it's 115% of 65. The next problem was a little bit trickier. Just figuring out what the question was asking me, I had to make a little chart thinking, okay, I have 2014, that's $300. It's going to increase by 10%, and then it's going to increase by another 25%. Notice this is not the same thing as a 35% increase. because this original 10% is off of the 300, but now I have a new number that then is getting increased by 25%. So this new number is going to be bigger. So 25% of this bigger number is going to be different than 25% of a smaller number. So taking a look here, answer $412.50 in 2016. So you could think about this as you have your $300 of the cost, you're increasing it by 10% of those $300. Then you're taking a 25% of that and adding it to how much money it was in 2015, which is the $300 plus 10% of $300. I know it gets a little confusing. So this is just the price in 2015, the $300 plus 10% of $300, and then you're adding 25% of that price in 2015. Or you can think about it as we're taking 110% of 300. So it's that 100% of 300 and the 10% of 300. And then whatever that number is, we are taking 125% of that number. And when you do that, you also get the same answer. And the final question that we are doing today is our dinner problem, very similar to the last lesson. We have our dinner, which is 100% that we have to pay of $34. We have to pay our tax, and we have to pay our tip. We can take our 100%, our $34, plus 10% of our $34, plus another 15% of our $34 to add up to get $42.50. Or we can think about this as 100% plus another 10% plus another 15% of $34, which makes 125% of $34, which also gets you $42.50. Thank you so much, mini mathematicians. Looking forward to see you live and in person next class, and we'll finish up this. Have a wonderful, fabulous day.